rectangles to approximate area. And we're going to do the intro, and we're going to learn this stuff. RRAM means right-hand rectangular approximation method. LRAM is left-hand rectangular approximation method. And MRAM is midpoint rectangular approximation method. And then we may or may not get to data tables. And if we don't get to the data tables, then I'm going to have to remove some of the homework. But let's go for it. Adding rectangles to approximate area. Adding up rectangles to approximate area. As I've said many times before, when you know information about the rate of change of a quantity, that gives you important information about the total quantity itself. For example, let's say, the classic reservoir. Let's say I had a reservoir, and I happen to know the flow rate into or out of the reservoir. And the units of the flow rate, let's say it's gallons per minute, okay? So I know the flow rate into or out of the reservoir, and it's given in gallons per minute. And let's say I had a graph. I had a graph of time versus flow rate. And my time will be in minutes, and my flow rate will be in gallons per minute. So let's say that's 50, and this is 1, 2, 3, 4, alrighty. And let's say this was my graph. For the next 4 minutes, the flow rate into the reservoir was a constant 50 gallons per minute. Well, you tell me, how many gallons just flowed into my reservoir? How'd you get that?
50 times 4.
Yeah, 50 times 4, right? 50 gallons per minute for 4 minutes, 50 times 4. But do you see that what you actually did was add up the areas of these rectangles? You said the first minute I got 50 gallons, 50 times 1, 50 gallons per minute times 1 minute, 50 gallons per minute times 1 minute, right? And do you see how the minutes cancel and you get 50 gallons? Okay, so you got the area of the first rectangle, then the second rectangle, then the third, then the fourth, right? Getting that area was really just getting this total amount of water that flowed into the reservoir was the same as getting the areas of those 4 rectangles and adding them up. You guys okay with that? Okay, so let's do another one. Let's do one a lot more complicated than that. Here's 50, and here's 30. And this is flow rate in gallons per minute. And this is time in minutes. And suppose 1, 2, 3, 4. Suppose it went like this. For 2 minutes, it was like that. And then the flow rate abruptly changed to 30. And for 2 minutes, it's like that. Okay. Well, now, how much of this stuff flowed in? How much water flowed in?
160.
You guys getting 160?
Yeah.
Sure, right? Because these 2 rectangles are, here's 50 plus 50 plus 30 plus 30, so it's 160. That was easy. Let's do another one. Here's flow rate, here's time. I'm just going to do time and flow rate, which I'll call Q. And suppose this graph looked like this. Here's 50. Like that. Now, I don't get to just add up these nice little rectangles because my graph is all curvy. So you know what I'm going to do? Anyone thinking add up a bunch of little rectangles?
Yeah.
That's what we're going to do. I'm going to say, you know what? Even though it's all curvy, I can divide this into a bunch of little rectangles. So what I do is I just divide this into a bunch of partitions. That's what these are. These are partitions, okay? I'm going to divide this into partitions and then get the area of all of these rectangles and then add up all those areas, and that's going to be the amount of stuff that flowed in. The problem is, now that I've made all these partitions, because my graph is curvy, I've got to decide what the height of my rectangle is. Here, it was easy to choose a height for the rectangle because every one of these lines was horizontal. But what happens when my line is curvy? How do I choose what the height of my rectangle is? Well, in this class, in high school class, you're going to have three choices. You can choose the height of this rectangle, and remember, that's the only issue. What's the height of the rectangle? I know I can get this width, okay, but what's the height? The height is either going to be the y-coordinate of the leftmost point of every partition, the y-coordinate of the rightmost point of every partition, or the y-coordinate of the midpoint of every partition. And those are going to be your three choices for the height of your rectangles. So, hey, let's actually do some problems now. Here comes example number 1. F of x equals radical x plus 1. Approximate area between f of x and the x-axis from x equals 0 to x equals 4. Well, what would you have me do first?
Graph it.
Sure, let's graph it. Thank you very much. So here we go. Here's 1, 2, 3, 4. Here's my x's. Here's my y's. 1, 2, 3. When x is 0, y is 1. When x is 1, y is 2. When x is 4, y is 3. So here's my graph. Now, next step, I have to choose the number of rectangles. Now the thing is, on tonight's homework, you don't get to choose it, I choose it for you. N equaling 3 or 4 or 5. But how many rectangles would you like to use here?
3, 2.
2 rectangles?
Yeah.
Just that guy and that guy?
Heck yeah.
Well, okay. Is that going to get you a very well, okay, let's try. Is anyone thinking 4 rectangles? No one. Oh, thank you, Jacob. Thank you. Okay. Well, he wants to use these heck bent on using 2 rectangles. Let's use 2 rectangles. All right. We use 2 rectangles. That means n equals 2. N is the number of partitions, which means the number of rectangles. Okay? So I've got 1 rectangle that's going to go from there to there, and 1 rectangle from there to there. To get the area of a rectangle, I need to know 2 things, right? I need to know the width and the height. Let's go ahead and get the width. What's the width of each of these 2 rectangles?
2.
Good. 2. Generally, if you want to know the width of a rectangles, you do this. You say, okay, let's say the first point is A and the last point is B. That is, this guy is my A and that guy is my B. Then it turns out that the width of your rectangle, which we're going to call delta x, ends up being B minus A over N. Sometimes I ask my students, tell me what it is, and I fish for the answer. But in this case, I'm not going to. I'm just going to tell you. So in this case, it ends up being 4 minus 0 over 2, which is 2. Yay. So I got the width of each rectangle as being 2. Now it's time to choose the height of the rectangle. Tell me, do you want the height to be the y-coordinate of the rightmost point of each partition, the y-coordinate of the leftmost point of each partition, or the y-coordinate of the midpoint of each partition?
Middle. Me.
Well, you guys are all saying midpoint, but I'm gonna go with right, just because that came first. You guys okay? So look at this first rectangle, alrighty? The y coordinate of the rightmost point is right there, correct?
Yeah.
So I'm gonna make a rectangle whose height is the y coordinate of the rightmost point. Look at this next rectangle. What's the height of this rectangle? The y coordinate of the rightmost point. So I'm going to approximate the area under this black curve by adding up the area of this rectangle to the area of that rectangle. So I'm going to say the area is approximately equal to the width, 2, times the height, which is going to be f of 2, plus the width 2. Or do you mind if I just write it delta x? I'm going to start off by writing delta x times f of 2 plus delta x times f of 4. Are you guys okay? That's the area of those two rectangles. So the area is going to be 2 times, what is that? 1 plus radical 2 plus 2 times 3. So I get an area of, just a second, 2 times plus radical 2 plus 6. So I get 10.83. That's what I'm approximating the area under this black rectangle, which, by the way, is this area here. This black area, I'm saying, is approximately equal to the blue area. Now, is that blue area too big or too small?
Too big.
Yeah, too big, okay? And I want to remind you again, this was RRAM. RRAM, which is right hand approximation, rectangular approximation method. Right hand rectangular approximation method. And the thing that distinguishes RRAM is the height of every rectangle is the y coordinate of the rightmost point of every partition. RRAM. Height of every rectangle is y coordinate of the rightmost point in each partition. You know what? Here's the last thing I'm going to do. So tonight, I don't think I'm going to really assign any homework tonight. We'll complete this tomorrow. So if you wanted to get a start on your review Xeroxes, that might actually be a good idea. Because here's what I'm going to do now. I'm going to have you do that same area, but by using left-hand, by using LRAM, left-hand rectangular approximation method. You guys ready for that?
Yeah.
Sure. Example number 2. Approximate area between f of x equals the square root of x plus 1 and x-axis from x equals 0 to x equals 4 using LRAM and n equal 2, just 2 rectangles. Good luck. Please do that now. By now, everyone should be getting that the height of this first rectangle is 1, and the height of this second rectangle is whatever the heck that y coordinate is. So you're adding this area to that area. To approximate the area under that black curve. To approximate this black area. So you guys getting 6.83? Anyone get 6.83? Okay, yeah, man, you did good. You guys okay with that? Okay, and then, hey, last but not least, that was LRAM. Okay, here comes example 3. Do it with MRAM, where MRAM is the midpoint rectangular approximation method. I'll do it with red. Tell me, look at the first rectangle. Uh-oh. Well, we'll continue this tomorrow. No big hurry. Oh, look who almost walked in.